Hello everyone. Today we will make a revision about 3 lessons: 12.3 inscribed angles, 12.4 angle measures and segment length, and 12.5 circles in the coordinate plane. The inscribed angle, as we said before, is an angle whose vertex on a circle and whose sides are chords of the circle. This is the inscribed angle. And the intercepted arc is an arc whose endpoints are on the inscribed angle. The measure of the inscribed angle equal half the measure of the intercepted arc. For example, if the intercepted arc AC, if it was, for example, 70 degree, then the measure of angle B, the inscribed angle, equal half 70, equal 35. Let's solve this question. Find the measure of angle BAC in a circle O. Here we have 57 degree. This is measure of angle BOC, the central angle. And we know that the measure of the central angle the same as the measure of the arc. Then arc BC the same, 57 degree. And we know that measure of angle BAC as this is inscribed angle, then equal half the measure of this arc, half measure of arc BC, the intercepted arc. Then measure of angle BAC, the inscribed angle, equal half 57 is 28.5. How to find the measure of angle A? Measure of angle A here, this is inscribed angle, equal half the measure of the intercepted arc, the semicircle, 180, then half 180 equal 90. How to find the measure of angle A, B, C, and D? Measure of angle A, this is inscribed angle, intercepted the arc BCD. Let's find the measure of the intercepted arc BCD. This equal 100 plus 90. Then measure of the intercepted arc BCD equal 190. Then measure of angle A equal half 190 equal 95. By the same way, let's find the measure of angle B. Measure of angle B intercepted the arc CA. And we know that the arc CA equal the sum of 90 and 64. Then measure of arc CA equal 154. Then measure of angle B, the inscribed angle, equal half 154 equal 77. The same as measure of angle C. To find the measure of angle C, then look at the intercepted arc DB. The intercepted arc DB here equal the sum of the two arcs 64 plus 106 equal 170. Then measure of angle C, the inscribed angle, equal half the measure of the intercepted arc 170. This equal 85. And also we can find the measure of angle D by looking at the intercepted arc ABC that equal the sum of 106 plus 100 equal to 106. Then the measure of this inscribed angle D equal half 206 equal 100. What is the measure of each numbered angle? Angle 1. Since angle 1 inscribed the semicircle, then equal half 180. Then measure of angle 1 equal 90. Measure of angle 2, since measure of angle 2 and angle 38, both of them inscribed angles intercepted the same arc, then both of them are congruent. Then measure of angle 2 equal 38. What is the measure of each numbered angle? We have quadrilateral. Then remember that the quadrilateral that is inscribed in a circle, then each two opposite angles are supplementary. By finding measure of angle 1, measure of angle 1 here, inscribe the semicircle equal half 180, then measure of angle 1 equal 90 degree. And also measure of angle 3, this inscribe the semicircle, then also is right angle equal 90 degree. By finding measure of angle 4. Measure of angle 4, this is inscribed, intercept the arc 60 plus 80, then equal half the measure of the intercepted arc 60 plus 80, then measure of angle 4 equal half 140, then equal 70. And we know that measure of angle 2 supplement measure of angle 4, then measure of angle 2 equal 180 minus 70 equal 110. The tangent and the intercepted arcs. Here, by looking at this tangent from the point C, the angle that formed by this tangent and the chord BC, this angle equal half the measure of the intercepted arc BDC. Let's apply this theorem. Here we have tangent SR, and the measure of the arc PMQ equal to 112. This is as we see in the given. How to find the measure of angle PQR? Since we have tangent, then the angle PQR equal half the measure of the intercepted arc PQ. Let's find the measure of the arc PQ. Here, as we see in the given, the measure of the arc PMQ 212, then the remaining of this circle equal 360 minus 212, then measure of the arc PQ equal 148. And the measure of the angle PQR that formed by the tangent SR and the chord PQ equal half the measure of the intercepted arc PQ, then equal half 148 equal 74. Let's solve this example. Here we have tangent KJ, this tangent to the circle O. What are the values of X and Y? Here, by looking at the angle QJL, this is an inscribed angle, inscribe the semicircle, then its measure equal half the semicircle, then equal 90 degree. By looking at the triangle QJL, here we have two given angles. The angle Q equal 35 and the angle QJL equal 90. Then we can find the measure of angle Y by subtracting from the interior angles of the triangle, or by subtracting from 90, because the sum of angle Q and angle Y equal 90 degree in the triangle. Then angle Y equal 90 minus 35 equal 55 degree. Here we have tangent, as we see in the given. KJ is tangent at the point J, and we have chord JL. Then the angle X here, this angle equal half the measure of the intercepted arc, because formed by tangent and chord JL, then equal half the measure of the intercepted arc JL. Here the intercepted arc JL, this equal twice the inscribed angle Q, 35. Then measure of the arc JL equal 70 degree. Then the measure of the angle that formed by the tangent and the chord JL, angle X, equal half 70 equal 35. At the first, let me identify what does it mean by secant. Secant is a line that intersects the circle in 2 points, like the secant here. As you see, the secant AB intersect our circle in 2 points. Angle X here formed by the intersection of the 2 secants, or the 2 lines here. Then measure of angle X here equal half the sum of measure of the two intercepted arc. That means measure of angle x equal half the sum of 46 plus 90. Then measure of angle x equal half this sum 46 plus 90 equal 136. Then half 136 equal 68. By looking at the other question here, how to find the measure of this arc Z, according to this intersection was outside our circle, whatever if this line, one of them tangent or both of them tangents or both of them secants, it doesn't matter. The same idea, we will apply our theorem. Then measure of angle 20, this one equal half the difference, as we said, half the difference of the two intercepted arc 95 and arc Z here. Then by multiplying both sides by 2, then 40 equal 95 minus Z. By solving this equation, we will get that Z, the measure of this arc, equal 95 minus 40, then Z equal 55. Let's solve another example. What is the value of each variable? Like variable W. Here we have angle formed by intersection of two lines outside this circle. By applying the same idea, then this angle equal half the difference of the two intercepted arcs. That means 70 equal half the difference of the intercepted arc W, and arc 110. Then by solving this equation, we will multiply by 2 for both sides. Then 140 equal W minus 110. Then by solving this equation, we will get that W equal 250. By looking at the next one, how to find the measure of angle Y. This is the same idea. An angle formed by the intersection of the two secants. Then here measure of angle Y equal half the difference like the first question. Then measure of angle Y equal half the difference of 110 and 30. Then measure of angle Y equal 40. How to find the measure of this arc X? Here we have two secants intersecting inside this circle. Then measure of angle 35 supposed to equal half the sum, yes, half the sum of the two intercepted arc X and arc 30. Then 35 equal half X plus 30. Then by multiplying by 2 both sides, then 70 equal X plus 30, then X equal 40. By solving these two questions, find the value of the variable. According to our theorems, we said if we found the two secants intersecting outside this circle, then the product of their segment and the whole secant are equal. That means 6, the outer segment, times the whole secant, 6 plus 8, equal 7, the outer segment, times the whole secant, 7 plus y. This both of them equal. Let's solve this equation. 6 times the sum 14, this equal 84. 7 using the distributive property, 7 times 7, 7 times y. Then 84 equal 49 plus 7y. By solving this equation, we will get that 7y equal 35, then y equal 5. In the other question here, we have secant and tangent intersecting outside this circle. Then according to our theorem, we will apply that the outer segment 8 times the whole secant 8 plus 16 equal the square of the tangent z. Then z squared equal 8, the outer segment, times the whole secant 8 plus 16. By solving this by distributive property, then z squared equal 192, then z equal 13.9. Let's solve the other question. What is the value of the variable to the nearest tenth? By the same idea, we have two secants intersecting outside this circle. Then the product of their outer segment and the second are equal. That means 14, this is outer segment, times the whole second, 14 times 20. This equal 16, the outer segment, times the whole second, 16 plus x. By using a distributive property, 14 times all the sum 14 plus 20, this equal 476, the same as this one, 16 times 16, 16 times x. Then we have an equation, 476 equal 256 plus 16x. By solving this equation, we will get that 16x equal to 120. By using a division operation, we will get that x equal 13.8. By solving the other question here, we have two chords intersecting inside the circle. Then the product of the segment of each secant are equal. That means 3, the segment, times 7 equal 6.5 times 3. 6.5 times m. Then by solving that, here 6.5 m equal 21, then m equal 3.2. Now let's solve this question. What is the standard equation of the circle with center 5, negative 2 and radius 7? At the first, let's write our equation of the circle. X minus h squared plus y minus k squared equal r squared. We know that the coordinate of our center 5, negative 2, then h here is 5, okay, and k is negative 2. By plugging those numbers in our equation, we will get that x minus 5 squared plus y plus 2 squared equal 7 squared. Then by making squared to the radius, we will get that 7 squared is 49. Then this is our equation. Next question. What is the standard equation of the circle with center 1, negative 3 that pass through the point 2, 2? Here we don't have the radius, but we can use these informations to find the radius and to write our equation. At the first, x minus h squared plus y minus k squared equal r squared. And we know that h is 1 and k is negative 3. By making a substitution, we will get that x minus 1 squared plus y plus 3 squared equal r squared. Here we will use the other point as x and y. After that, we will make substitution in our equation to find the radius r. Then 2 minus 1 squared plus 2 plus 3 squared equal r squared. Then r squared equal 1 plus 25. Then r squared equal 26. Now I have all the pieces that I need. I can make substitution in this equation to write that r squared is 26. Then this is our final answer. X minus 1 squared plus y plus 3 squared equal 26. Let's see another question. This is another type of questions. We need to find the center, radius, and graph our circle. Here from this question, x minus 8 squared plus y squared equal 9. Let's write our equation or the standard form. X minus h squared plus y minus k squared equal r squared. By looking at here, this h is 8, but y here, since y is no y minus some number, then this k would have to be 0. Then the center is hk is 8, 0. Here we have the radius squared equal 9. Then the radius is root 9, then equal 3. Then we have the radius and we have the center of the circle. By plotting the point, the center of the circle 8, 0, like that, and draw the radius 3. After that we can draw our circle. The next question, x plus 2 squared plus y minus 4 squared equal 7. And also we have to remember our equation, the standard form of the circle, the equation of the circle. Here, since we have h and k, as you see here, how to figure out the sign of the number. Here, h and k, remember that always h and k, they have the opposite sign of your question, the opposite sign. You have to change the sign of h and k. Then since here we have x plus 2, then h is negative 2. And here we have y minus 4, then k is positive 4. The radius squared equals 7, then the radius equal root 7. Then we have the center of the circle negative 2, 4, and the radius root 7. As you know, root 7 is in between 2 and 3, or you can use the decimal if you want. Then let's plot the radius negative 2, 4, and we will put the center of the circle negative 2, 4, and draw the radius that in between 2 and 3. After that we can draw our circle like that. The last question, here write the standard equation of each circle. This circle, how to write the standard equation? From the given here we have the center. As you see, the coordinate of the center is 2, 2. And the radius, this radius, if we count the squares, we will get that 1, 2, 3, 4. Then the radius of the circle is 4. Then since we have the center and the radius, we can write the equation of the circle as x minus 2 squared plus y minus 2 squared equal the radius squared. 4 squared is 16. Thank you for listening and have a nice day.